Download this code from codegive.com, link in the description below. Cross-site scripting, XSS, tutorial for bug bounty hunters. Cross-site scripting, XSS, is a web security vulnerability that allows attackers to inject malicious scripts into web pages viewed by users. XSS is particularly dangerous because it can be used to steal cookies, session tokens, or any other sensitive information accessible through the browser. Types of XSS. 1. Stored XSS. The malicious script is permanently stored on the target server, example in a database, and is served to users when they view the affected page. 2. Reflected XSS. The script is reflected off a web server, usually via URL parameters. It is not stored and only affects users who click on a specially crafted link. 3. DOM-based XSS. The vulnerability exists in the client-side code rather than the server-side code. The attack is executed when the client-side script modifies the DOM environment. XSS attack example. Here's a simple example of a stored XSS vulnerability. Let's assume we have a web application that allows users to submit comments. Vulnerable code, server-side. Python. Assume this is part of a Flask web application. From Flask import Flask, request, render underscore template. App equals Flask, underscore underscore name underscore underscore. Comments equals. At approot, slash comment, methods equals post. Def post underscore comment. Comment equals request.form comment. Comments.append, comment, storing user input without sanitization. Return render underscore template, comments.html, comments equals comments. At approot, slash comments. Def show underscore comments. Return render underscore template, comments.html, comments equals comments. If underscore underscore name underscore underscore equals underscore underscore main underscore underscore. App run, debug equals true. HTML template, comments.html. HTML. Doc type HTML. HTML lang equals n. Head. Meta char set equals UTF-8. Title comments slash title. Slash head. Body. H1 comments slash H1. Form action equals slash comment method equals post. Input type equals text name equals comment required. Button type equals submit slash button. Slash form. ul. Percent for comment in comments percent. Li comment slash li, dash vulnerable to XSS dash. Percent and for percent. Slash ul. Slash body. Slash HTML. Payload example. An attacker could submit the following comment to exploit the XSS vulnerability. JavaScript. Script alert, XSS attack, /script. When this comment is submitted, it will be rendered directly into the HTML, causing an alert box to pop up whenever someone views the comments page. How to find XSS vulnerabilities as a bug bounty hunter. 1. Identify input fields. Look for input fields, URL parameters, or any way a user can submit data to the application. 2. Test for reflected XSS. Craft a URL that includes a script. http://example.com/search, q equals script alert, XSS/script. Check if the script executes in the browser. 3. Test for stored XSS. Submit a comment or form with a script payload. JavaScript. Script alert, stored XSS/script. Check if other users can see the script execution. 4. Test for DOM-based XSS. Inspect the client-side JavaScript for functions that manipulate the DOM using untrusted input. Use browser developer tools to test for script injection. Reporting XSS vulnerabilities. When reporting a vulnerability, ensure you include 1. Vulnerability type. Specify whether it is stored, reflected, or DOM-based. 2. Steps to reproduce. Provide clear instructions on how to reproduce the vulnerability. 3. Impact analysis. Explain the potential impact of the vulnerability, example data theft, session hijacking. 4. Mitigation advice. Suggest how the developers can fix the issue, such as using proper input sanitization or escaping. Example report template. Subject: stored XSS vulnerability in comments section. Description: there is a stored XSS vulnerability in the comments section of the application. Steps to reproduce. 1. Go to the comments page. 2. Submit the following comment. JavaScript. Script alert, stored XSS, /script. 3. Reload the comments page. Impact: any user who views the comments page will execute the injected script, potentially leading to cookie theft or other malicious actions. Recommended fix: sanitize user input using libraries like DOM Purify or encode outputs to prevent script execution. Conclusion: cross-site scripting is a prevalent vulnerability in web applications. Understanding how to find and report XSS vulnerabilities is crucial for bug bounty hunters. Always remember to follow ethical guidelines and responsible disclosure practices when reporting vulnerabilities to ensure a positive relationship with the application owners.